Hello everyone, my name is Ben Hickey and I'm here from F5. I'm the head of Volterra Business Development and Sales for APAC, and today I'm going to talk to you about iterative innovation with multi-cloud and edge. As you will all know, applications are changing and today they are all being built on microservices and serverless architectures. This is delivering huge amounts of agility and enabling people to innovate much more quickly than they used to before. It's allowing teams to specialize on key functions and for application components to be broken up to follow the fastest innovation path that each one can. You will have also known about APIs for a very long time. What's different now is that APIs are really the only method to access infrastructure and application components. In the past, people may have used things like command line, but really today, in the infrastructure as code manner, we want to drive everyone to using software and APIs. And lastly, we'll talk a fair bit today, but multi-cloud deployments are becoming the norm. Many traditional organizations have had to deal with heterogeneous environments as they move to the cloud, first adopting hybrid, and many digital natives actually started out in the cloud, so didn't have this problem. But as they've grown and cloud companies have continued to differentiate their offerings, digital natives even today find themselves using multi-cloud architectures in order to take advantage of the best of breed cloud services being provided by the hyperscale companies themselves. Now, that is actually something that we're doing all around increasing agility, which is innovation and iterative innovation, to scale and to allow operations to scale with the actual development team, and to allow us to manage our TCO and costs while we're doing that scaling. Breaking that down, the research shows us that 92% of all enterprises and small medium enterprises declare that they are multi-cloud today. But when we look under the hood, we see that 49% actually have their applications siloed on different clouds with no need for them to ever communicate. This is common in early stage companies or companies that have lifted and shifted particular applications to certain cloud providers, like finance applications going to one cloud provider, whereas new applications are built in another IaaS cloud provider. And today there is no reason for them to talk. However, many enterprises, of the 92%, 29 to 45 in particular, have declared architectures that are reliant upon hybrid and multiple public cloud. Some of these are multi-cloud for business continuity reasons, like high availability and failover. We've seen a very common hybrid use case for traditional organizations where front-end systems have been moved to the cloud to adopt microservices to enable agility and take advantage of cloud economics, while back-end systems that are difficult to re-architect remain on-premise. We've seen best-of-breed cloud providers come to market with tooling around data to provide data lakes, visualization tooling, and AI and ML specifics that are not only technically superior, but are also financially, commercially superior, meaning that even companies today that started out in one cloud provider start to add second cloud providers for those specialist analytic skills. And lastly, another common one is the environment cloud, where teams don't just move dev test workloads, but they actually split their environments based upon development, functional testing, non-functional testing, staging, and production, and use cloud tools to maintain those environments for consistency, to allow their teams to move quickly without running into issues. So really, we've seen over this time, people move from on-premise data centers to hybrid cloud, taking advantage of those early cloud economic benefits, pay for what you use, and scale without commitments up front. Then we've seen multi-cloud, as we just talked about, where organizations take advantage of advanced application architectures to deliver key capabilities for their business. But then going beyond this, we see the distributed cloud and distributed edge as really where things are going, not only for IoT, but really for running compute in containerized environments that are constrained by resources. That could be anywhere from a retail outlet, a factory, even electric vehicle charging stations. The cars themselves could become mini data centers running containerized workloads. And if you think about, as we spoke about on the panel at this event, data science, analytics, and AI/ML hold a lot of promise for the future. But these, in this equation, the other part of the equation is where do we get the data from? And that's where this distributed cloud is going to unleash huge amounts of data available to those centralized cloud functions to really change how we all experience the internet and cloud today. However, this does not come without a cost, and operational complexity has grown. Many different teams, your development teams that have been combined with ops like DevOps and NetOps and SecOps are all trying to manage this infrastructure, often at the same time, using different tooling and different systems with different levels of maturity. This makes it very difficult and sooner or later ends up being a scaling bottleneck. There is an opportunity for your teams to be unblocked, and the best way to do that is, of course, with a cloud-based platform. So here we have F5's Volterra platform today, which is a SaaS platform with a global backbone that provides a number of products that can be deployed onto any of the major cloud providers today or into your own environments, allowing you to connect applications to applications in a consistent manner for your security and your other policies, no matter which public cloud they're on or which on-premise cloud they're on, or how small or distributed the edge is. And this consistency is a huge benefit to your teams. Now, these teams, if they're in this space, this multi-cloud space today, will no doubt be having challenges. How do you connect two different public clouds together in a reliable and consistent way when each of the tooling in the independent clouds is proprietary and unique to their environment? A key way to avoid lock-in here is to use a tool and to use the F5 Volterra platform to connect those two environments together so that your policies are consistent no matter which public clouds or even which on-premise hybrid cloud environment they're applied to. But even people that have been running with cloud for a while, they run into problems within a single cloud instance just due to scaling. It's not uncommon for an enterprise to have hundreds and even thousands of virtual private clouds or VNets in their environment. And each one of those needs to be configured with a security and network policy to enable them to connect to the rest. So doing this in a consistent manner to avoid security becoming the villain in the story that is the last person to come along and say that a deployment must be held up. We can now use tools that are baked into the infrastructure to automate it and to make sure that these key capabilities are part of the actual development process at the front end. And the third case here is when we start to get to the really distributed edge and cloud, and we're running modern applications based on Kubernetes. But it's not, Kubernetes is fantastic in terms of enabling innovation, but when you start to run at scale, the administrative overhead and providing the infrastructure for the Kubernetes clusters is non-trivial. Managing thousands of clusters is a real problem for many teams. And so being able to virtualize clusters and manage clusters as a fleet, and be able to do that in a standard manner where all of your existing Kubernetes APIs and commands and definition files remain consistent, is a real advantage to teams operating these edge locations where, as an example, a customer of ours had an EV charging station deployment where over 3,000 locations ran mini containerized workloads so that they could process the data downloaded from cars when they were charging. Those 3,000 EV charging stations were able to be managed as a fleet and virtualized into 8 geographically based clouds. So those 3,000 endpoints became 8 endpoints. So putting all that together, F5's Volterra is a solution for adaptive applications where your teams can come together and use a common platform-based tool that is delivered via SaaS for each of their independent needs. And that you do not have to restrict yourself because it will work on any on-prem, any public cloud, and any edge location. So that's my talk for today. I thank you very much for your time, and I wish you all very well.